the binomial expansion example 2. Find the fifth row of Pascal's triangle and then binomial expansion of this bracket, this binomial x minus 2 over x to the power of 5. Okay, so let's do it. In part A, let me try to construct the fifth row of the Pascal's triangle. So this is the 0th row. Now this is the first row, 1 and 1. The second row actually is 1, 2 and 1. So you know how these numbers are obtained. Number 2 is 1 plus 1 and number 1 and 1 are just added. Now again I add number 1 here. 1 plus 2 is 3, 3 plus 2, 2 plus 1 is 3 again, and 1 is added. Again add 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4 and 1. And for the fifth row, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and finally we have 1. So this was the 0th line of the Pascal, or row of the Pascal's triangle. This is the first, this is the second, third, fourth, and the fifth row. So we have the fifth row here, and these are actually the coefficients that are going to appear in the binomial expansion of a plus b to the power of 5. So I can write it here. A plus b to the power of 5 is going to be a to the power of 5 plus 5 times, so the first coefficient now, this one, 5 times a to the power of 4 b to the power of 1 plus 10 times a to the power of 3 b to the power of 2 plus 10 times a to the power of 2 b to the power of 3 plus 5 times a to the power of 1, which I do not need to write, times b to the power of 4, and finally plus b to the power of 5. So this is the binomial expansion. What I have used is the following pattern. The powers of a start at 5 and have to decrease by 1. So 5, 4, 3, 2, 1, 0. Powers of b, the powers of b start at 0 and have to increase by 1. So there is 0 here, b to the power of 0, which is not written there because it's 1. Here I have b to the power of 1, b to the power of 2, to the power of 3, b to the power of 4, and b to the power of 5. The sum of powers of a and b is always 5, so you see 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, and you have 0 plus 5 is 5. And finally, I have used the coefficients from the fifth row of the Pascal's triangle. So 1, 5, 10, 10, 5, 1. Now let me expand this bracket. So in part B, we have to expand x minus 2 over x to the power of 5. Now we have to identify what a and b is. So this number here is the number a, and we can write it as plus minus 2 over x to the power of 5. So this number here with minus there would be b. Okay, so perhaps instead of using the round brackets around the expression, I should go for a pair of square brackets like that. So this is our expression, and now we'll use this formula to write down the expansion. So first a to the power of 5. So in my case it's x to the power of 5 plus 5 times now a to the power of 4, which is x to the power of 4 times negative 2 over x, just like that, plus 10 times a to the power of 3, which is x to the power of 3, times b to the power of 2, so b is negative 2 over x to the power of 2, plus 10 times a to the power of 2, so it's x to the power of 2, times b to the power of 3, which is minus 2 over x to the power of 3, plus 5 times a, which is just x, times b to the power of 4, so it's minus 2 over x to the power of 4, and finally plus negative 2 over x to the power of 5, because that's b to the power of 5. This equals and I can now try to simplify. So it's x to the power of 5. Now here we have 5 times negative 2, so it's minus 10. And now you see you have x to the power of 4 divided by x, so it's just x to the power of 3. Okay. Now this third term, you have this negative number which you have to square it. Now if you square it, it's positive, so there is plus. Negative 2 squared is 4. 4 times 10 is 40. And we have x cubed, I can write it, over x squared, because x to the power of 2 is x squared, plus. Now actually it's not going to be plus but minus, because this is the odd power of a negative term, so we get negative answer. So it's 2 to the power of 3, which is 8, minus 8 with the minus, times 10, it's minus 80 x squared over x to the power of 3, because x when raised to the power of 3 becomes x to the power of 3 in the denominator. Then we have a positive term, because that 4 is the even power, so you have to have plus here. 2 to the power of 4, it's like 16, and 16 times 5 should be 80. Let me check it. Yes, it's 80, so it should be 80 times x over, and here I have x to the power of 4, and finally I have the negative term, because 5 is an odd power, so the negative 2 to the power of 5 must be minus 32, so it's 2 to the power of 5 is 32, minus 2 to the power of 5 is minus 32 over x to the power of 5. And now I can simplify even further, so it's x to the power of 5 minus 10 x to the power of 3, now plus, and you see that this is just 40x. Then you see that you have minus 80 over x, because if you divide x to the power of 2 over x to the power of 3, you have x to the power of negative 1, which is 1 over x. Yeah, you see, plus 80, and you have over x to the power of 3, you can cancel 1x here, and minus 32 over x to the power of 5. And this should be the expansion. So you see that the signs in the expansion are alternating, so you have plus, minus, plus, minus, plus, minus, which is in line with the idea when we have a minus b, or actually something minus something to any power. So the signs should be alternating, which they really are. So yeah, this is it.